All right, hello people who are gone and watching this video. This is 5.2. This is the start of section 5.2. I like this section. This is binomial probability distributions. I want you to first circle this word. Binomial probability distributions, okay? We did probability distributions before where we have like the probability of sleepwalkers and that type of thing. We had like tables set up, okay? Binomial means two. We only have two probabilities. Something happens or something else happens, whatever, right? So we're not talking about like 5 sleepwalkers. We're only talking about something happening, okay? I'm going to give you an example. Okay, I do not have a green thumb. So the probability of Mrs. Comacher killing a plant in my house is like 80%. Will give me 20%, okay? That's being generous. The probability that I'm going to kill a plant is like 80%. It's probably closer to like 95, but we're going to give me 20%, okay? So the probability that the plant lives is going to be 0.2, right? Okay, and the reason why this is binomial is because there's only two options. Either it lives or it dies, right? There's only two options, live or die, right? Every binomial probability distribution can only have two options, okay? Something happens or something else happens, right? Probability distribution, live or die, okay? Now, they're going to ask me a question. So given that information, that's past experience, given that information, 80% of the time I kill a plant, right? Okay? They're going to say, now, if I have, let's say, 10 plants, what is the probability that exactly 5 live? Right? Well, let's do exactly 4 live. I'm going to change that number so it's not 5 and 5 because that's going to be a little confusing in our numbers, right? Exactly 4 live, okay? Is that too high of a number? 4 living out of 10? Given my past experience? Given my past experience, how many should live? 2. So I'm trying to like up my game here, and I'm going to say, what's the probability that 4 is going to live? So is it a really high probability that 4 is going to live? No, because only 2 should live, right? 2 should live out of 10 because I have a 20% chance of them living, right? Okay, so we're looking at this from the live perspective, all right? And here is how this works. This is a binomial because there's 2 options, and then we're looking at some other things over here. So we have this information, okay? And I'm going to label this as P and Q. Are you ready for this? Okay, so we have to label P's and Q's, and we're going to say P is the probability of kill, and Q is the probability of live, right? Okay? P, Q, whatever. They label it as P and Q. And then we have 2 more variables, and these are the only 2 other variables that are associated with this. We have an N, and we have an R. They might call it N and X instead of N and R. I do N and R because, like, NPR, NCR, those are the variables that we use for NPR, NCR. So we have an N and an R. Okay? Based on this information, what is N and what is R? 10 is my total number of plants that I have, right? How many do I want to live? 4 are living, okay? Okay, good? All right, so the formula for a binomial, I'm getting ahead of myself, but you guys are catching on. This is pretty easy, is, are you ready for this? Put this over here. It is NCR P to the R, Q to the N minus R. That's a little bit of a confusing formula, but write it down. I'll show you how it works. It's not that hard. Don't make it that hard, okay? This is the formula that they use. Really, there's only 3 parts to it. I'll show you how this works. Okay? NCR, P to the R, Q to the N minus R. Whatever. Okay? Just wait. We'll get there. Okay? All right, good? Good? They make the formula more confusing than it is. I'm going to dumb it down a lot. I'm going to dumb it down a lot. Here we go. Are you right? You ready? There are 3 parts to this. There's this chunk, which we do NCR, okay? So NCR in this case would be 10C4, yeah? That's the first chunk, okay? Whatever that number comes out to be. We don't know yet. Whatever. If you want to do this in chunks, you can. 10C4. Then the second chunk is P to the R, okay? Don't complicate this. We have 2 options. We have a P and a Q, right? Okay? P is 0.8 and I need to raise that to some power, and Q is 0.2, I have to raise that to some power. So this is my P part and this is my Q part. So I have to figure out what this exponent is and what this exponent is, right? Okay? And don't get confused with the exponents that I've listed here. R and n minus r, don't get confused with that. Okay, you ready? Here's how I'm going to explain this. Okay, these two exponents that I have up here. 0.8 was what? What did that represent? That's kill plants, okay? Given my scenario, how many plants will die? No, 0.8, but given my scenario, if I'm wanting 4 to live, 6 will die. So I put 6 with the 0.8. Does that make sense? Let me put that up here a little bit darker. 6 goes there, yeah? 6 goes with the kill rate, right? 0.8 was my kill rate, and I'm killing off 6 of them, right? How many in my scenario did I want to live? 4, and 4 goes with the live rate. Does that make sense? Yeah. So I look at my kill rate, and I look at my live rate, and I put the exponents according to what I want to have happen in my scenario. Does that make sense? Yes? And this is going to give me the probability. Okay? Yes? Good? All right, so here's what I want you to do. In your calculator, type in 10C4 and tell me what that number is. Eventually, we'll get to the point where we'll type all this in together. Okay? 10C4 is how much? 210. What? 210. Okay, so this number is 210. And what is 0.8 to the 6th power? Big number, like a long decimal number. What's 0.8 to the 6th power? What? 0.26214. We'll go 0.262. Oh, just go to 0.2621. We'll go 4 decimal places. 0.26221. Now do 0.2, which was my live rate, times how many I want to live, or to the live power, right? 0.2 to the 4th power. 0.0016. Okay. Then I'm going to multiply all those together, those three parts, okay? And what is the probability that exactly 4 of them are going to live? Now we said it's not a very, it's going to be not a terribly high probability, right? 0.0881. That's like an 8 or a 9% chance, okay? If I have an 80% kill rate, and I'm talking about 4 out of 10 plants living, I have a 9% chance that that's going to happen, right? That's pretty low, because more should die, right? More should die than 4. If I have an 80% kill rate, I should have more than 4 live, right? Or less than 4 live, right? Okay? That's how you do a binomial thing. Is this confusing? Okay, let's do another example. We'll get it in our heads. Down here, they're talking about what P's and Q's are. Okay? P is the probability of success. Q is the probability of failure. You can switch those around. It doesn't matter what you would designate as P's and Q's. It does not matter, okay? The fixed, N is the fixed number of trials. They use X. I used R in this case. So if you want to cross that out and put R, that is A-okay. All right? So we have P, Q, N, and R. Those are the 4 things that we need. P, Q, N, R, those are the 4 things that we need in every single one of these binomial problems. Just those 4, okay? All right, when an adult is randomly selected with replacement, don't worry about that stuff, there is an 84% chance, or a 0.84 probability, that the person knows what Twitter is. So we're talking about yes Twitter. We're talking about yes Twitter, okay? And then we're talking about no Twitter. Okay, so people that are yes Twitter, you have an 85% chance that you're yes Twitter, yeah? Okay? 85% yes Twitter. No Twitter would be 15.15, right? Yes Twitter, no Twitter. 85%, 15%, okay? We have to label one as P and one as Q. What do you want? Yes to be P, no to be Q. It does not matter which one you designate, because in the formula, it doesn't matter, okay? Yes to be P, no to be Q. So that's what those guys are, all right? Then it says, suppose that we want to find the probability that exactly 3 of 5 randomly selected people know what Twitter is. That determines what N and R are. What is N going to be? The total number. 5. I'm selecting 5 people, and 3 is R, okay? Now, are we talking about those 3 people knowing Twitter or not knowing Twitter? No Twitter, right? That's what they said. 3 of 5 know what Twitter is. So this 3 is going to be yes Twitter. Okay? I'm designating that to go together. Does that make sense? Okay, so A, does this procedure result in a binomial distribution? Is this binomial? Yes, because we have two options. You either know Twitter or you don't know Twitter. Those are my two options. So this is a yes. And then B says if this procedure does result in a binomial, identify the values of x or nx, which we called r, p, and q. Okay, we did that. Okay, let's go ahead and calculate this because we know how, right? The formula was NCR P to the R, Q to the N minus R, but don't get bogged down that because like our R's and N minus R's might not be right. Okay, so you just have to like look at what you're talking about. Look at the three chunks. NCR will be 5C3. Okay, and then let's write out what the P value is. Okay, P was 0.85. Q was 0.15, and then we have to find the exponents that go with each one and make sure that they're on the right spot, okay? So 0.85 was yes Twitter. Of the 5 people, how many do I want to say are yes Twitter? 3. So this goes here. This is 3, and what's the other one? 2. Does that make sense? Okay? So the 3 is, so just make sure that those match up because sometimes you'll switch those around and put 2 in the wrong spot and 3 in the other spot. So 3 is going to be my yes Twitter. That has to go with the 0.85. Q is the 0.15. That's 2 people not knowing. Okay. If you want to try to type that in all at one shot in your calculator, you sure can. Do you want to try it? Yeah. Okay. 5C3. If you have to, you can put multiplication symbols in between these two. It's like those 3 chunks multiplied together. If you need to do that. Okay. You should be able to type that all in at one shot. What? You can use, you don't have to use parentheses actually. If you use multiply, you don't have to use parentheses. Okay, so if you want to type it in as like 5C3 times 0.85 to the third times 0.15 to the second, you can use either parentheses or the times button. You don't have to use both of them. If you want to use both of them, you can. 0.1381? Yeah. What? It rounds up to 2, okay. So 0.1382? Yes? So there's like a 14% chance that 3 of them are going to do whatever. 3 of them exactly are going to know Twitter, right? 0.1382, yeah? This is not terrible, right? Okay, just the formula. You have your 4 pieces. That's it, okay? Good? All right, I'm going to stop there. Do you want me to give you your homework assignment? You can start, like, I think the front page of the first example is just identify NPQR. You can get a head start, okay? Where is my button here? Ah, there we go.